Okay, so we're going to talk with growth and decay. This is the exponential equations, except for they're used very particularly to represent a couple things, either a growing population or a shrinking population, or it doesn't have to be population, it can be money also. But these are the two equations. I assume that probably if you thought about it long enough, you could realize a plus sign represents growth and the minus represents decay. Okay? R is the rate that it's changing. So if it's percentage, you want to change it to like 3% is the same as 0.03, 5% is 0.05, etc., etc., etc. A common growth rate equation is actually this. It's the interest equation, where R is still your interest rate, P is your starting amount, and up here, I should have said this, your A is your starting amount, T is usually in years, can be months or whatever it says. This one, P is your starting amount, it's also known as your principal, that's why they put a P there. R is your interest rate, N is the number of times it's compounded, I'll talk about that more in a second, and T is the number of years you let it grow. So the prize for a radio station contest begins with a $100 gift card. Once a day a name is announced. The person has 15 minutes to call for a prize, or it increases by 2.5% for the next day. Find the equation for it. How much would the gift card be worth? So first off, is it increasing or decreasing? Hopefully you realize that the prize was increasing, and 2.5% is the same as 0.025. So I'm plugging it in, and then I have the starting amount. That's what goes out here. Last time I checked, it looked like it was 100. And T is the number of years that or days in this case. So here, because of the fact that it's this, I'm going to have to actually back out of this so I can do the calculator for you. I would type that into my calculator, which will give me a second to boot up. 1,000 now. Oh, even perfect. $100 plus 0.025. And how many days is it? Carrot keys, I do 10 because it's 10 days. So it'd be approximately $128. So it's really not that much more. But, you know, the more you wait, I guess the bigger the prize. Whatever they want, right? Okay, so I'm going to put this in the back. It's going to make me open it again here in a second. But now let's talk about interest rate. This equation is important. You will use it many a time between now and probably you're done with your math. This is actually the interest rate banks use. So you start with how much you invest. And then you put 1 plus your rate divided by how many times it's compounded. So this word then points to my next word. Monthly tells me it's 12. And that 12 goes here again. And then how many years do they leave it? 22. Okay? So once again, I'm going to back out of this. I'll leave this here long enough for you to write it down. But then I'm going to use the calculator to actually calculate this. Okay? Hopefully you have it down by now. It's gone here. So I'll grab this. How much money was 300? 1 plus the interest rate divided by how many months, or how much it's compounded, which is 12 because there's 12 months in a year, to the power of this, I have to put parentheses on, 22 years times the number of times it's compounded, which is 12, means that after 22 years, it's just a little over double. So that's a good example of the interest equation. We'll use that probably many a time to practice tomorrow or whenever we get to this. Population of Campbell County, Kentucky has been decreasing at an average rate. Decreasing tells me it's going down. Notice the 0.3% per year. Once again, I'm going to write this, then I'll go back to the calculator. So how much does it start with? Its population started at 88,647 in the year 2000. And I get to subtract 0.003. And then how many years are we going? From 2000 to 2010? Tells me 10 years. So do note that that's 0.97, right? Okay, once again, I'm going to wait a second for you to copy that down if you want to. Now I'm going to go to the calculator. 88,647 times, remember it's 0.997 to the 10-year power. $86,023. And since, do note that, on this and this one and this one, they have their own rounding principles. So like this one, since we're dollars, you probably round to the nearest dollar. This one, round to the nearest, well, actually round to the nearest cent. And usually they'd round down because they want to save money. So they round this one down. There you go. This one, since it's people, you'd sit with that as your answer, probably rounding to the nearest person. So I'd go with this one. Okay? If that doesn't make sense, we'll talk about that in class 2 when we do these examples. But that's it. If you have any questions, you can always email me or come see me. Otherwise, have a good evening, and I'll see you soon.